Hello everyone. Today I'm going to continue talking about visualization and working on the data set that I showed you to see how we can generate, how we can create graphs with this data set. Okay, so two main packages that we are going to use again. And I'm going to start with generating a data using, let me write down, data using NumPy random dot randn and 6, and then I'm going to create index for this data set using pandas date range. You should remember this from 1/1/2020, and then for how long? For n. Okay, so what is n? N is the number of arrays, means number of rows. I'm going to create 1000 rows, and here I'm going to say this is a data set with n rows and 6 columns. You can change the columns, right? Let me make it 4. It's better. 4 is better. Okay, so I'm going to create columns name. So how many columns do we have? 4, right? I'm going to name it group 1, group 2, group 3, and group 4. So if I had 6 columns, I should have 6 names, right? I have 4 columns, therefore 4 columns name, right? Okay, so we created index, column, and now we are going to set up our data set. So our data set is going to be panda data frame, right, using the generated random data, and then index that we created, right, and then the next argument is columns, and we are going to let me here do something. So index names, so you don't get confused between this argument and what variable we created here. Okay, so now I think it's much easier for you. So these are the variable I created, and then I'm saying columns is equal to variable I created, index is equal to index that I created, right? So I'm creating a data frame using the random data and assigned index, assigned columns. So what I'm going to do, I'm going to print the first 5 rows, right? Data set dot head, and let's say first 10 actually, because always I'm choosing 5, so you don't think that it's always must be 5. Okay, so now if you remember cumulative summation, this is a method, and then I'm going to plot this cumulative summation for each of them, and then I'm going to use PLT. Where's the PLT? Did I do that? No? Oh, Okay, so where's the graph? What was the graph's name? Well, okay, here, import math plot lib as library, pyplot as plt, right? Okay, so now you understand what this plt is here. So plt, now plot it. plot. Okay, so what did I do? Oh, okay, so see, just one parenthesis I forget here, and I didn't have the graph. Do you see that? So I created a data set with dates. I'm showing just first 10 rows, right? Showing the first 10 rows here, right? And then I'm calculating the cumulative sum for each column, right? And then using plt to plot all the cumulative sum for the columns. So for each column, imagine we have created a cumulative sum and plotted them, right? And then here we combined all of them, and here's the legend. Blue is for the group 1, which is column 1, and then group 2, column 2, and so far. So imagine this data set could be like this. So people's, for example, income would be the variable 1, and then you would draw the income for each year, and then how many numbers we have for 1,000 years, 1,000 dates, right? For example, the next variable would be the car price, a specific car price during all these years, day by day, date by date, right? 1,000 information. And then other one would be like price of house or some other things. We are comparing 4 different variables together during the time, right? Okay, so now this is the time series plot again, right? So what I'm going to do, well, you know what? Please always remember, import all the packages in case you're resetting the kernel and you're starting everything all over again. Okay, so let's go to the path that I saved the data set here. And the data set is this one. I read the data set using CSV from this path with this data set CSV name, and then I'm naming the columns, and then header 0 because I'm renaming the columns, right? And then index column is a state, and what else? That's it so far, right? And I created the data set here. Now what I'm going to do here, I'm going to create dates, just generate dates for this data frame, right? Using date range, and let's say 1/1/2016, because as you know, this data set doesn't have columns of date. I removed that. And then how many dates I want to be generated. I have 50 states, right? And then I'm going to do 50 here, right? And then I'm going to say print the data set shape in case I forgot what's the dimension of graph. So why do I receive error here? Pandas has no attribute date range. Should have. Oh, range. Okay. Oh, I should not fix it. I should ask you. That's fine. Okay, so I'm going to shape. Shape gives us the dimension. So what was the rows, number of rows and columns in our data set, in case we forgot. Okay, so good. So 50, I wrote down 50 here, right? And let's continue. What I'm going to do, I generated dates just as a practice for you. Maybe it doesn't make sense at all to have dates, fake dates for the data set, but doesn't matter. I'm just practicing to see how you can generate data set, generate a column of data set and attach it to your data set. So what was my data set name? This is my data set. How can I attach a column to that? In this way. I'm going to open a bracket and then writing down the column's name and what is the column that I'm going to add to my data set. The column is the dates that I generated, right? And then now I'm going to do something that I didn't do before. I'm going to use Panda package data frame to make sure my data set is becoming a data frame. So to make sure the data set is a data frame class. And what I'm going to do, I'm going to print this data set only the first 10. Okay, so look at this. The first 10 states, we attached a new column, which is the date. Okay, so there are two ways actually. I wanted to mention that. There are two ways to print a specific column. For example, I want to print out the column region. I can do this. I can print the column region using dot notation, right? Let me print okay, so one is this way. I can see the column region this way. Another way is print data set, our data set, and then I'm going to open a bracket and then write down the column's name. These are two different ways that we can extract our data set, columns of our data set, or this one. So remember, there are two different ways to extract the column. Cut here, paste here. Two different ways to display a column from a data frame. Okay, so now the next one, what I wanted to do, well, we know that region is a categorical variable. We know that What is the other variable? Percentage of graduation, minority percentage. All of these are quantitative variable. And then this one, these two are also categorical variable. Okay, so first of all, I have a question for you for your participation. How many graphs we can use to show a categorical variable? Name them. How many? Name them. Another question. How many graphs can be used to show quantitative variable? Just one quantitative variable. Name them. So I'm just talking about one single variable. To visualize one quantitative variable, how many graphs we can use, and what are the names of those graphs. For categorical variable, to display only one categorical variable, how many graphs do we have, and what are the name of those graphs? So this will be your participation point for this lecture. Okay, so I'm going to import the plot, panda, and numpy, and then I'm going to create a sub data from the data set we have. How? LOC, and I'm going to use bracket, all the rows, but certain columns. Which columns? I'm going to choose these 3 columns. Okay, and then let's see what I have here. Print the first 10. Now you will see I have just 3 columns here, right? Creating a sub data set only with 3 variables. Okay, so I'm going to comment this out. So what I'm going to do, I'm going to draw a graph. This graph is a scatter plot which shows 2 variables, 2 quantitative variables together, the relation between 2 quantitative variables. Okay, so FIG, figure, AX, these are 2 attributes of plot, PLT dot subplot, this is a method. So this is a method of PLT that we know is matplotlib pyplot, and then these are 2 attributes of this plot. So we are setting these 2 attributes to subplots of this plot, and now we are creating colors. How? This is the dictionary. Later maybe we talk about dictionary. Dictionary is also a kind of form of data set with a key and the rest of information. We talk about that later. For now, just see what I'm doing. I'm creating a kind of data set for each of region. I am assigning a color. So northeast, west, south, and then MW, which is the last region we have, and then I'm going to say yellow. You can assign any different color. So I have 4 different region, 4 groups. I have 4 groups in region and assigning each group a color. These colors are already defined. This yellow, red, the way I wrote down, no capital, no, no other way. This is the only way you write down blue, which is defined in plot. And then I created a data set color, and then I'm going to use this attribute and the scatter, which is a method to create a scatter plot, to create a scatter plot. And then I'm going to say the x-axis of this scatter plot is the sub data that I defined here, created here. Sub data dot this one, or what else I could show? I could say something like this, right? Instead of writing down the whole thing like this, I could write it down in this way. And then y equal to, I'm going to draw a scatter plot of x versus y, graduate percentage, minority percentage, right? And both of them are numerical. So a scatter plot of two numerical variables separated by, actually this one is not separated by it, numerical variables, and then quantitative variables, right? So x, y, I could say x is this one and y is this one, so depends on you how you want to show it. And also one more thing, in a statistic it's important, if you know which variable, which of these two is a response variable, that goes on y-axis. If you know which one is explanatory variable, that goes on x-axis. Remember this, okay? And then C, which is for color, this is another argument, is going to be, where is that? Region. So actually, I'm separating it by region already. So what I'm doing, I'm coloring the points by the region, right? I'm going to separate them like this. It's more neat, right? Okay, I think we are good to show the graph using dot show. Use dot show to show the graph. Hopefully everything is correct. Let's see. No, what's going on? C argument must be color. And oh, sorry, I forgot. So in the next graph I'm going to do that. In here I'm going to write down sub data dot region dot map the colors. So what is this colors? This is the one I defined here, right? And this AX is going here, right? And then let's draw it now. Look, we have we draw a X versus Y with X variable versus Y variable, separating by region. What is missing here? There are lots of things missing. I don't know what is X. I don't know what is Y-axis. I don't know anything unless I say plot X labels. This is another method that we can use to assign a name to, for example, X. What was X? X was grad percentage, right? And then I'm going to say plt dot now Y label, and minority is going to be y-axis. What else? I'm going to use plt.title, and I'm going to give it title scatter plot of this one versus this one. What else? Let's see if we can draw a legend for this. Legend. I hope it shows that. Okay, so legend doesn't show that. But I have another trick to show the legend. Okay, so do you see that we have X label, Y label, and the title for this graph. Okay, so you will write all of this down before showing the plot. Okay, so now again, using another way to draw a scatter plot to show the label properly. Let's see what we can do. We are going to again do all of this. I'm going to create a subgraph, and then I'm going to again have figure and colors, right? And then what I'm going to do now, I'm going to create a variable group, and then I'm going to group the subdata. Group them by, this is a method, by what? Region. Okay. Group the data by region. And then now I'm going to use for key. So these are the key. These are the key in the dictionary we have here. For key and group is going to be from here. In grouped, comma, group dot plot, and now AX is equal to AX. Kind of this graph is scatter. X is equal to this one. Y is equal to this one. What I need, okay, we should label them. Label is going to be the key. I said key south, west, northeast, these are key. MW. And then what? Color should be equal to colors, the one I created, and the key. Okay, so we are grouped them by the key, we are color them by the key. And what we are going to do, plot dot show. But what do we do before that? We're going to copy all the X label, Y label, and title. Look, now we have a legend here, grouped and colored by the groups of region. Okay, so let me write down here. Keys are parts of dictionary. How do we write down dictionary? Dictionary. Am I right? I don't think so. So let me search this. Oh, I was right. Okay. Part of dictionary. Colors that I made is a dictionary. Keys are S, W, Northeast, and MW. Okay, good. So now I'm going to show categorical variable region, as we know. So what I'm going to do, so this is just a scatter plot. Now I want to show this region using bar graph and pie chart. So what I need to know what is the frequency of states that are in south or states that are in W. How I can do that? I can use table equal, actually using dot cross table in pandas. So I'm going to use panda dot cross table. Index is the data set region, right? Column is equal to frequency. I'm naming the column in this way. I got the region from the data set, and then I'm creating the column name because I'm creating a small data frame that shows the frequency of, what did I do wrong here now? It says crosstab got an unexpected, oh, here we need S. Okay, so frequency of each state, there are 12 times MW repeated in our data set, 9 times NE, or we can say 16 states are under south category, and then 13 states west category. So we need this table. Now what I'm going to do, I'm going to create another table using panda to make this a data frame, to make the table I created a data frame, and then I'm going to print the new data frame I made out of the previous one. Okay, so now what I'm going to do, I'm going to import plot, import panda, and then using PLT figure to open a figure, blank figure, and then I'm going to use region frequency data set dot FREQ, which is one of the variables in the table. Do you see that? You know what, let me create a print here, oops, and then here, so we can separate them. So frequency is the column's name, right? I brought it here, and then I'm going to plot it, and then what's the kind of plot? It's going to be bar graph. And as you see, I have regions with their label and the frequency on y-axis. So this is the bar graph, and I can do the same thing here. And instead of bar graph, I use pie chart. Now here's the pie chart I have. I can copy this again, and then I design my pie chart furthermore. How? I'm going to create more argument here. This is going to be 0 to F. I will explain to you what is this. And then I'm going to create labels, and I'm going to name the labels. So maybe you want to change the label's name right later. And then S, and then W. And these labels name will be in order that you see in here in this graph. MW first, North East. So if you want to rename that, in order to rename the labels, please pay attention to what you already have in region frequency. Data frame. Okay, and then this is a note for labels, right? And then what else I'm going to do? I'm going to say now I want to change the colors. This is another argument. And then R for red, G for green, B for blue, and what is C for? It stands for, I don't remember. Clay, sorry, clay. I chose it, I don't remember it. Okay, so you can go to plot this package, search this package, and search for colors that this package offers. So you can find all of these different color and the name they have, because you should always choose the correct name, otherwise it will give you an error and say there's no this kind of color. Okay, so as you see, I put the percentage inside each of the slices and then rename this, and then let me say group 1, then you will see how it changes. Look, changes this way. And what else? Oh, here 0.2%, 0.2 will put the percentage in here with 2 digits after decimal on the right side of decimal. If I change this to 1, you will see just 1 digit after decimal. If I change it to 3, you will see 3 digits after decimal. And so this will replace the percentage for you in each slice. Okay, so this is for today, and I will next lecture I will continue with more visualization, and I hope you have your questions for me. And don't remember, you can label all of them. And also, if you're more curious about designing these graphs, you can easily search this package and find all the arguments, attributes, methods, whatever this package has. There are lots of help for you. Okay, take care of yourself. Have a good day.